Everyone, in this video we will learn how to verify Thevenin theorem for AC source using multisim, and we will also learn how to find potential difference between the two points when the circuit has phase angle and complex component, and we will also see how to find Thevenin equivalent resistance when the circuit has complex component like inductance and capacitance. We will see all these in this video. For that, we will first make the circuit and analyze step by step. For that, we need one AC current source and one AC voltage source. And now we need resistance. We will change the value of resistance later. First, we will make the circuit and then we will change its value. We also need one inductance. So for inductance, go to basic and then inductor. Rotate it by pressing Ctrl R. Now we need to make this circuit. For that, connect this current source to resistance R1. As you see, our circuit is completed. Now we have to change its value. R1 is 1 ohm and inductance has value 6.3 millihenry. And R2 is 5 ohm. And load resistance is 1 kilo ohm. So it is a load resistance, so we change its level as RL. Now we have to change current source value. It has magnitude 2 and angle 45 degree, and frequency is 50 Hz. Peak to peak current is 0, and for voltage source, peak to peak voltage is 0, frequency is 50 Hz, and magnitude is 10, and phase angle is 90 degree. As you see, our circuit is completed. Now we will first find equivalent impedance. For calculating equivalent impedance, we will first copy this circuit and paste it below it. For calculating equivalent impedance, we need to remove this AC source and AC current source and AC voltage source and complete this. And we also need to remove load resistance. And now we need impedance meter for calculating equivalent impedance. We need to set this frequency to 250 because we are using 50 Hz frequency for our sources. Now we will run this simulation and see what is the output. As you see, our output is 1.24, which is. Now we need to calculate Thevenin equivalent voltage. For that, first we shift this circuit side. Now to calculate Thevenin equivalent voltage, we will copy this circuit and paste it below. Okay, here is this. We will paste it over here. Just sit slightly. Okay. Now we need to find Thevenin equivalent voltage. For that, we need to find it across load resistance. First, we will remove the load resistance. For calculating the potential across this point, we will put a voltage pointer here and another voltage pointer here. As you see, its name as PR1 and PR2. Now click on interactive, click on single frequency, set frequency as 50 Hz, and as you see output, it is already added VPR1 and VPR2. It means potential at PR1 point and potential at PR2 point. Now we add expression. So we need to find the potential difference. So potential difference is voltage at point 1 minus voltage at point 2. So we will add this expression as voltage 1 minus voltage 2 and click on add and save. And now we run this simulation. As you see, the potential is, as you see, our output is in real and imaginary form. You can also change its format as magnitude and phase form and run. Now our output, to make equivalent circuit, we need one voltage source, and for that we will click on, here we have AC voltage source. We will use this, and now we need impedance. For impedance, I will use resistance only, because impedance which contain in real and imaginary part is not available in my multisim version. So here I will use only resistance, and now we need load resistance. We will copy this and paste it. So first we have to change its value. We will keep same value, like this is our potential difference, that is Thevenin voltage. We will keep this same value, like peak to peak voltage is 0, frequency is 50 Hz, and magnitude is 6.48, and phase angle is 112.43. And also we have to change our impedance value. So our impedance value is 1.75, that is 1.75 ohm, and load resistance value is 1K. Now we will connect this circuit. As you see, our Thevenin equivalent circuit is ready. Now we need to verify this circuit. To verify this circuit, we need to check current flowing through load resistance is equal or not, or we have to check the potential across the load resistance. We will check the current flowing through this circuit is same or not. If the current flowing through this circuit is same, then our circuit is also correct. For that, I have added that current pointer in both of the circuit. Now we will go, as you see, current pointer is already added. We just need to run this simulation. As you see that here PR3 and PR4, PR3 and PR4, has same value. Thank you for watching this video. If you found it informative and useful, please subscribe to my YouTube channel.